In this video, we will learn about the interpreter design pattern and how to implement it using C++ code. It is a behavioral design pattern that defines a representation for a language and an interpreter for that language. A real-world example of this is Roman numerals. In Roman numerals, I is a value of 1, II is a value of 2, III is a value of 3, IV is a value of 4, V is a value of 5, and so on. Let's take a look at how we would code a Roman numeral interpreter program using C++ code. Up at the top of the code, we will include the vector header file. Next, we will create a class named context. Inside of this class, we will use the public access modifier. Let's add a constructor for this class that takes in one parameter of type string named I. Inside of the body of the constructor, we will set input equal to I. Then we will have an int named output and a string named input. After that, we will create a class named expression. Inside of here, we will use the public access modifier and create a virtual function with a string return type named 1, a virtual method with a string return type named 4, a virtual function with a string return type named 5, a virtual function with a string return type named 9, and a virtual function that returns an int named multiplier. Then we will have a function that returns an integer named interpret, which takes in a pointer to a context object named context. Inside of this function, we will check if the length of the context's input, which is the Roman numeral string we are going to translate to a base 10 number, has a length of 0. If so, we will return 0. Then we will check if the context's input starts with a Roman numeral corresponding with a value of 9, which we can do by utilizing the rfind function and passing in a call to our 9 function as the first argument and 0 as the second argument, and checking if the output of that equals 0. Inside of this if statement, we will set the context's output equal to the context's output plus 9 times a call to our multiplier function. Then we will set context's input equal to context's input with a substring from index 2 to the end of the input. If the Roman numeral corresponds to a value of 4, we will add 4 times the multiplier to the context's output, and then adjust the input string accordingly to account for the value that we just processed. Then we will check if the input string starts with a value corresponding to 5, and if so, we will add 5 times multiplier to the output, and then adjust the input string. After that, we will use a while loop that runs while the input starts with a value of 1. Inside of this while loop, we will add 1 times multiplier to the output, and then adjust the input string by setting it to the substring from index 1 to the end of it. Outside of the while loop, we will return context's output. Next, let's create a class named thousandExpression that extends the expression class with public accessibility. Inside of this class, we will define a function that returns a string named 1, which will return the string value capital M. Our next function will return a string, be named 4, and return a space. Then we will have a function that returns a string named 5, which returns a space. Then we will have a function that returns a string named 9, which will return a space. After that, we will have a function that returns an int named multiplier, inside of which we will return 1000. Next, we will create a class named hundredExpression that extends the expression class with public accessibility. Inside of this class, we will implement the 1 function, which will return a capital C, the 4 function, which will return a capital CD, the 5 function, which will return a capital D, the 9 function, which will return a capital CM, and the multiplier function, which will return 100. Then we will create a class named 10Expression that extends the expression class with a public accessibility. Inside of this class, we will implement the 1 function, which will return a capital X, the 4 function, which will return a capital XL, the 5 function, which will return a capital L, the 9 function, which will return a capital XC, and the multiplier function, which will return an integer value 10. Then we will have a class named 1Expression that extends the expression class with public accessibility. Inside of this function, we will implement the 1 function, which will return a capital I, the 4 function, which will return a capital IV, the 5 function, which will return a capital V, the 9 function, which will return a capital IX, and the multiplier function, which will return 1. Time to test our code. Inside of C++'s main function, we will have a string named Roman, which we can set to the string capital V, I, which is 7 in Roman numerals. Then we will create a pointer to a context named context that we set equal to a new context object with Roman passed into the initializer. Next, we will have a pointer to a thousand expression named thousands that we set to a new thousand expression object. After that, we will create a pointer to a hundred expression named hundreds that we set to a new hundred expression object. Next, we will have a pointer to a 10 expression named tens that we set equal to a 10 expression object. After that, we'll create a pointer to a 1 expression named ones that we set to a new 1 expression object. Then we will create a pointer to an expression named exp set equal to thousands. Let's create an int variable named thousands result that we set equal to a call to exp's interpret function with context passed in. Then we will set exp equal to hundreds. Let's create an int variable named hundreds result that we set equal to a call to exp's interpret function with context passed in. After that, we will set exp equal to tens. Let's create an int variable named tens result that we set to a call to exp's interpret function with context passed in. Next, we will set exp equal to ones, and then have an int variable named ones result set to a call to exp's interpret function with context passed in. Finally, we will output Roman, then an equal sign, and then the sum of thousands result, hundreds result, tens result, and ones result. When we run the code, notice that 7 was output, meaning our code works. Great job.